In this lesson, you'll learn to use theoretical and experimental probability to represent and solve problems involving uncertainty, and perform simulations to model real-world situations involving uncertainty. How can probability simulations be used in healthcare? A pharmaceutical company is developing new medication to treat a certain heart condition. Based on similar drugs, researchers at the company expect the new drug to work successfully in 70% of patients. To test the drug's effectiveness, the company performs 3 clinical studies. Each study involves 100 volunteers who use the drug for 6 months. The results of the studies are shown in the table. The probability we have used to describe events in previous lessons is theoretical probability. Theoretical probabilities are determined mathematically and describe what should happen. In the situation above, the expected success rate of 70% is the theoretical probability. A second type of probability we can use is experimental probability, which is determined using data from tests or experiments. Experimental probability is the ratio of the number of times an outcome occurred to the total number of events or trials. This ratio is also known as the relative frequency. So experimental probability is frequency of an outcome, just like favorable events, over total number of trials. Miguel shot 53 throws in the gym and found that his experimental probability of making a throw was 40%. How many free throws did Miguel make? First, we want to write 40% as a decimal, so 0.4 of always means time, so 40% of 50 is 20. I find the problem a bit ironic because he already knew how many free throws he made. You would normally calculate the percent from the actual. It is often useful to perform an experiment repeatedly, collect and combine the data, and analyze the results. This is known as an empirical study. A pharmaceutical company performs 3 clinical studies to test the effectiveness of a new medication. Each study involves 100 volunteers. The results of the studies are shown in the table. What is the experimental probability that the drug showed no improvement for all 3 studies? So no improvement. And for all 3 studies, the total percent would have been 100. So 100 plus 100 plus 100 would be 300 for our total for the percent. So our favorable outcomes are 97 out of 300, which as a percent, and we may as well round to the nearest whole percent, would be about 32%. So I should have used about. A method that is often used to find experimental probability is a simulation. A simulation allows you to use objects to act out an event that would be difficult or impractical to perform. You can conduct simulations of the outcomes for many problems by using one or more objects such as dice, coins, marbles, or spinners. The object you choose should have the same number of outcomes as the number of possible outcomes of the problem, and all outcomes should be equally likely. In the last 30 school days, Bobby's older brother has given her a ride to school 5 times. What could be used to simulate whether Bobby's brother will give her a ride to school? Now this looks like it could be a contrived problem because 5/30ths reduces to 1/6. So this would be perfect to use a number cube, aka a die. Describe a way to simulate whether Bobby's brother will give her a ride to school in the next 20 school days. You could assign getting a ride as the number 1, roll the die 20 times, and record the results. Another good option that we'll explore is using a website such as random.org, which doesn't limit you to multiples of 6. You could use any random number. Allie raises purebred dogs. One of her dogs is expecting a litter of 4 puppies, and Allie would like to figure out the most likely mix of male and female puppies. First, they ask her to assume that the probability of male and the probability of female both equal 1/2. A common simulation for things that are equally likely, and there's only 2 outcomes, would be to toss 4 coins, or 1 coin 4 times, 1 for each puppy, with heads representing female and tails representing male. What is an alternative to using 4 coins that could model the possible outcomes of the puppies? You could use a spinner, or you could go to a website such as random.org that will either generate virtual coins to flip, or you could use numbers to simulate the process. Find the theoretical probability there will be 4 female puppies. Well, each puppy is equally likely to be male or female, so 1/2 times 1/2 times 1/2 times 1/2 will be 1/16. The results of a simulation Ellie performed are shown in the table. How does the theoretical probability there will be 4 females compare with Allie's results? Okay, so 4 females was 3 out of a total of 50 trials she did, which 3 divided by 50 is 0.06, so the two outcomes were very similar. So we found that the simulation was very close to the theoretical probability. Theoretical probability describes expected outcomes, while experimental probability describes tested outcomes. Simulations are used to perform experiments that would be difficult or impossible to perform in real life.